Welcome back, everybody. We're up to lesson 10 of Unit 2. And in this lesson, we're going to talk about something called the multiplicity of an X-intercept. The multiplicity is simply the number of times an X-intercept of a polynomial occurs. It's the exponent of the corresponding factors. So you might remember we've seen some polynomials in factored form that had exponents on the factors. That exponent tells you the multiplicity of the X-intercept. Now, what does the multiplicity actually do? What the multiplicity actually does are these two things here. So if I have a multiplicity of an X-intercept that is odd, that means the graph will cross to the other side of the X-axis. If the multiplicity is even, the graph will still intersect the X-axis. In other words, it will touch the X-axis, but it will not cross to the other side. So it's still considered an X-intercept because it touches the X-axis. It just doesn't cross over to the other side. So it has to do with the multiplicity being odd or even. If it's odd, it will cross to the other side. If it's even, it will not cross to the other side. So with that in mind, let's look at the examples for this lesson. So number one, sketch a graph for a polynomial function y equals f of x that has three different zeros and f of x is greater than or equal to 0 for all values of x. So those are the two requirements. So three different zeros, what does that mean? That means I have three different X-intercepts. So that means it's going to intersect the X-axis at 3 points. So to sketch it, I'm just going to pick three random points on the X-axis. So I'm going to pick here, I'm going to pick here, and I'm going to pick here. Okay? So that's the first requirement. The second requirement is that f of x has to be greater than or equal to 0. So greater than or equal to 0 means f of x has to be 0 or higher. So 0 or higher means it needs to stay above the x-axis. In other words, it's going to stay above it's never going to go below because the value of f of x is going to be 0 or higher. It won't go in the negative direction. So the only way that can happen is if the graph does something like this, and I'm going to use a different color. So I know it's going to intersect the x-axis here, but it's not going to go below the x-axis because it's got to stay 0 or higher, which means it's going to go back up, and then eventually it comes back down and intersects a second time. But again, it's not going to go below. It's not going to go negative because it stays 0 or higher, which means it's got to come back up and then eventually come back down. All right. And again, it's not going to go below, which means it's going to come back up and probably increase infinitely from there. So the only way that I can have three different x-intercepts and have it stay completely non-negative, 0 or higher, is if the graph looks something like this, almost like a funky-looking W, you could say. Okay. Number two, what is the smallest degree the polynomial could have? Well, if we look at this here, if we look at the three x-intercepts we have here, notice at each of these x-intercepts, it stays on the same side of the x-axis. It touches the x-axis, does not go to the other side. Touches the x-axis, does not go to the other side. Touches the x-axis, does not go on the other side. So it never actually crosses to the other side of the x-axis. If we go back and look at our lesson notes, okay, It says here, if the multiplicity of an x-intercept is even, that means the graph touches the x-axis but does not cross it. So that tells me that each of these x-intercepts has to have an even multiplicity. They each have to have an even multiplicity, which means the lowest number of times they could occur is twice. So this could have a multiplicity of 2, this could have a multiplicity of 2, and this could have a multiplicity of 2, because that's the lowest even number. It wouldn't make sense to have a multiplicity of 0, because that would mean it never occurs. So the least number of times, the least multiplicity that each x-intercept could have is 2, which means the smallest the degree could be is 6. Why 6? Because 2 plus 2 plus 2 is 6. 2 plus 2 plus 2 is 6. Okay? Now, number 3, what is a possible equation for this polynomial? Use graphing technology to see if your equation matches your sketch. So let's first look at my x-intercepts. My first x-intercept here was -8. So if my x-intercept is -8, we've learned in the past that the corresponding factor would have to be x plus 8, because we have to switch the sign. So for -2, my corresponding factor would be x plus 2. And for 2, my corresponding factor would have to be x minus 2. And if each of them has a multiplicity of 2, which again is the lowest they could be, then that means the exponents on each of the factors would have to be squared. So this would be a possible equation for the polynomial: x plus 8 squared, x plus 2 squared, and x minus 2 squared. Let's actually graph this on Desmos and see what it looks like. So x plus 8 squared times x plus 2 squared times x minus 2 squared. And if we zoom out here, let's see if we can get a better look at the window here. So I'm going to mess around with the window. You can see it comes down, then it comes up. Obviously, I need to go higher. So let's make this 400. Let's make that 600. So we're going to keep going up until we can see the whole thing. And you might have to do this on your computer as well. Okay, here we go. Here's a good picture of the graph here. And you can see it comes down, intersects at 8, stays above, comes up and comes down, intersects at -2, but stays above the x-axis, comes up, comes down, intersects at 2, stays above the x-axis. If we compare this graph to my original sketch, it's not obviously not exactly the same, but it's pretty close in that it comes down, comes up, comes down, comes up, comes down, comes up. Again, sort of like a funky looking W. Okay? So that is how we use multiplicities with polynomials. That is why multiplicities are important. And that is it for this lesson.